Yo, what's up? What's up? Precalc students, Mr. Mester coming at you. Talk about even odd functions, last lesson of Unit 5. Definition of even and odd functions. This is pretty simple, this stuff. It's a nice last lesson. It's not too complicated. If you're an even function, you think of it like the most basic even function out there, y equals x squared. What you see is a symmetry about the y-axis with the graph. Or if you take an opposite of an x, you're going to get the same as the positive x, or vice versa. We'll be able to check to see if this is true by plugging in negative x into functions and seeing if we get the same as positive f of x. Odd function, we see this kind of rotational symmetry where if you have this point here, we'll have the point reflected over the x-axis as well as the y-axis. Or what happens is if you plug in the opposite of x, you're going to get the opposite of f of x. Might be confusing this. Here, I'd put negative f of x is f of negative x. This might be confusing, but let's just show you 2 points. 3, 9. If I plug in 3, I get positive 9. If it's an even function, if I plug in negative 3, I should get positive 9, and I do. That's that symmetry. Here, talk about 2, 8. If I plug in negative 2, if I get negative 8, it's an odd function. Okay? If plugging in negative x is confusing, you can use a number to double check things. So let's get to it. For both situations, we're going to plug in the opposite of x and see what we get. Do we get just regular f of x, or do we get the opposite of f of x, or do we get something different? I'll do it with x's first, and then we'll do it with numbers to check. All right, so I'm going to plug in the opposite of x, and I'm going to use parentheses to make sure I don't make a mistake. And I get positive x squared, negative x squared is positive x squared, plus negative x. Now, what do I notice? This is not the opposite of f of x. This is not the same as f of x. So, this is a neither situation. Now, we can check with numbers. Let me check with numbers just to make sure. Start with just an easy number like 2 or 3. Don't choose 1. 1 can be confusing. Definitely don't choose 0. 2 or 3 are usually safe. If I plug in 3, I get 12. If I plug in negative 3, if I get positive 12, it's even. If I get negative 12, it's odd. If I get something else, it's neither. This is like probably the easiest way to check for you kids. I get 9 plus negative 3. Well, that's 6. That confirms it's even. What I'm going to do also is to graph, and just to show you the lack or the existence of the symmetry. The symmetry is about the y-axis. You might be like, this is symmetrical, but not about the y-axis. If I plug in this point 1, 2, I should get the point negative 1, 2, or negative 1, negative 2 to be an even or an odd function. I don't. I'll be right back. All right. Let's check this. If I plug in negative x, very important, keep all the symbols where they are. This is like, again, tricky to do with x's, so like double check with numbers. I'm plugging in negative x. Let's see what I get. 1 minus negative x squared is positive x squared. It's negative 1 times x squared. It's negative 1x times negative 1x. Negative x to the fourth is positive x to the fourth. That even power, negative 1 to the fourth. Now, what do I notice? This is the exact same as this. We have this idea of an even function. We can double check with numbers. Plug in 2. 1 minus 4 minus 16, so that's negative 19. If I plug in negative 2, still 1 minus negative 2 squared is 4. Negative 2 to the 4th is still 16. It works out to be the same value, okay? And we can graph to see the symmetry. Boom. The vertex, or it's centered around the y-axis, symmetry about the y-axis. How about this guy? For the rest of them, I'm just going to kind of plow through. You guys can use numbers to double check. Okay, I see this is the opposite of this, but this is not the opposite of this. This is a neither. This is not an odd. This is not an even. It's not equal to it, and it's not the opposite of it. Okay? It's either equal to the original function or opposite the original function. See? No symmetry. Okay. Negative x to the 5th is negative 1 to the 5th and x to the 5th. That stays as negative x to the 5th. Like, it's kind of confusing to see, but like I'll show you with numbers. This and this, they're opposites of each other. We have our first instance of an odd function. Odd function's kind of 180-degree rotation, a reflection over the y and x-axis. I look at x plus x to the 5th. I see that point and reflective point to this value, or like 1, this value, 1, 2, negative 1, negative 2. That's an odd function. Use numbers if you're not sure. F of 2 is 9. F of negative 2. If it's 9, even. If it's negative 9, probably odd. You should probably like double check that it'll work for all those values. If it's not either of those, it's a neither. 3 to the negative second is 1 over 3 squared, which is 1 over 9. This is a neither. It's going to be the same thing here. Let's use 4. Log base 2 of 4 is 2. I can't even plug in negative 4. So it's a neither. Let's plug in 3. Let's plug in negative 3. Okay, it's the same. Thinking that we're even. Double check. If I plug in negative x, get positive x squared plus 1. It's the exact same thing as the original function. Okay, so we see like adding values doesn't really affect being even or odd. Now we know that x cubed is an odd function. We might think that x cubed plus 1 is going to be an odd function, but it's not. To plug in 3, I get 28. To plug in negative 3, well, negative 3 cubed is negative 27 plus 1 is negative 26. This is a neither situation. Listen, if you are using numbers to check, once one number doesn't work out, you can say neither. If it does work out and it's the same value or the opposite value, you should probably think about checking more, showing that it's symmetrical for one point does not ensure that we know all of the points are even. This is why we should be using like negative x. Maybe like the idea for these problems is to use numbers first and then to double check with x's. I know this isn't going to work. Just because I know this is x squared shifted to the left 1. So it's not going to have the vertex at the y-axis. I plug in 3, I get 16. If I plug in negative 3, I get 4. It's a neither. Okay? Here's an example. Plug in 2, 2, 4, 8, 16, 32, 64, 128. If I plug in negative 2, I'm also going to get 128. Okay, good. That's like one point that works. Let's just double check. I mean, it's kind of obvious. 2 times negative x to the 6th is positive x to the 6th. So this is an even function. Okay, we got odd powers. What we'll find after doing all this experiment is that even functions always have even powers. You can add 1 or subtract. You can add numbers and subtract numbers. You'll still have the symmetry about the y-axis. So again, what we're saying is like, let's say I have x squared plus x to the 5th, not even. But if it's x to the 4th, if we have all these even powered, we're going to be even as a function. If you add numbers, we're still good. If you have minuses instead of pluses, we still have that symmetry. Even powers, even functions, symmetrical about the y-axis. However, if we change this to an odd powered, what we notice is that this is not symmetrical like we're looking for. I should have the point, let's go to 1. All right, well, like 0.916, 0.96. If this was odd, I'd have the point negative 0.916, negative 0.96, and I don't. You're not allowed to have a shift up or down for an odd function. For things to be symmetrical, rotationally, you really have to have like kind of center at 0, 0. You see this point 0.916 and negative 1.04 here. There we go. That's the opposite. You see this point 1.464562. You should have the negative 1.456, negative 2. Okay? So like that's the idea. Even functions, you're allowed to shift up and down because you're still symmetrical about the y-axis. Odd functions, you're not. Let's, again, double check with numbers first. Let's try 2. Let's try negative 2. Boom. Okay, now you got to keep track of like negative 2 cubed is negative 8. I have minus negative 8, that's positive 6. I see the opposite values. I'm thinking odd because at opposite x's, I get opposite y's. I'm going to double check with x's so that I ensure that for all x's, this is the case. Negative x minus negative x cubed. Negative x cubed is negative x cubed, which means this becomes plus x cubed. It's like tricky for you guys to show that and to know what to do with the negatives. This stays as negative x cubed, so you're minusing negative x cubed, which is plus. These things are opposites of each other. We have another odd function. It's tough to show odds. We think this is an odd function. We shift it down. It's not. Easiest way, 2, 4, 8, 16, 32. Wait, 2, 4, 8, 16, 32. Minus 2 is 30. If I plug in negative 2, it's negative 32 minus 2 is negative 34. Neither. Okay. All right, now that we know what to expect. Even functions, think of y equals x squared. Odd functions, think of y equals x cubed. Even functions, same values to the right or left of the y-axis. Odd functions, opposite values to the right of the left and the left of the really y-axis, or really the center 0, 0. You have to have that center of 0, 0 for an odd function. If this is an even function, here are some points on the even function. What are some other points? Well, f of 5, since it's even, has to be the exact same as f of negative 5. Again, think about even functions being like x squared. We have the same points to the right and left of the y-axis. F of negative 2 has got to be the same as f of 2. I'm getting better. I'm getting better, but it's slow. I'm finally on meds. F of negative 4, same as f of 4. Now, what do we notice? If you have an even function, no matter how you draw it, if you got a min on one side, you have a min on the other side. If you got a max on one side, you have a max on the other side. What must you have on even functions? Either a global minimum or a global maximum has to occur. If f of negative 5 is a relative max, well, f of 5 has to be a relative max. If f of negative 1 is a relative min, f of 1's got to be a relative min. Has to happen. Cool? Now, what about odd functions? Well, again, they're a little bit trickier, but you can kind of see if you look at like a cubic function or any kind of symmetrical. Oh, this is going to be tough. Oh, yeah, that was tough. Let me try to simplify it a little bit. Let's go and graph like. This is a good odd function. Let me see if I can add, or if I subtract x to the 5th. No, add. Let's see if I add x. I want to get like another. What happened? I had a good one. There, that's good. Let's see if I subtracted x to the 7th. If I can get. No. I forgot, like, how do I make it? So I have another. Whatever. You can see, if you have a max on one side, an odd function will have a min on the other side. We see the opposite values. If f of negative 5 is 8, f of 5 has to be the opposite of f of negative 5, which is negative 8. It's that rotational symmetry. Two reflections. Okay. If f of negative 5 is a max, there's that max maybe at f of negative 5. F of 5's got to be a min. That's how the symmetry's got to work out. If negative 1 is a min, so let's kind of draw another situation. Low, a little bit high, a little bit low, very high. This is perfect. This is an odd function. Okay. Min, max, max, min. Cool? If f of 1, f of negative 1 is a min, f of 1's got to be a max. Pretty simple. True, false, an even function is guaranteed to have a global max or a global min. True. Has to happen. Because you have to have the same end behavior. It's symmetrical. You'll have to end up and up. You'll have to, you might have two global mins, but it'll be the same location. You have to have a global min or you have to have a global max the statement is true. Everything's symmetrical. End behavior is symmetrical. You'll have to end up and up, which means you'll have to have a minimum somewhere. You'll end up down and down, which means you'll have to have a maximum somewhere, all dependent on that leading coefficient of your highest degree power. Now, odd function is not guaranteed. It's very simple. Your counterexample is x cubed or any x cubed. Here's an odd function that has neither a max or min. Because you see the end behavior is up to the right and then down to the left. So like we will not reach a maximum value. We will go towards infinities in both directions. However, you could, and we did this in the notes, you could have one, but you're not guaranteed to have one. Here's an example of an odd function that has both a global max and a global min. That's odd. So it's like it's possible to happen, but no, it's not guaranteed to have. Even functions guaranteed to have global maxes and global mins. Odd functions, if you have a max on one side, a relative max, you'll have a relative min on the other side. All right, let's do some fun like number stuff. We're told that we have an even function. Well, we got A, B, C, D, E are positive integers. What kind of manipulation of these numbers will lead to an even value? Now, here's the only thing that must be true. B and D must be even. A, C, and E can be anything. Okay? So A could be even or odd. C could be even or odd. If you want to, you could assign values for B. Maybe B is 4 and D is 2 as an example to help you. You can assign values for A. Let's say A could be 1 or 2. C could be 1 or 2. E could be 1 or 2. Like values that it could be. Could be anything. The coefficients aren't going to change. It's all about taking that negative x to an even power will be positive x to the even power. So what must be even? Well, A minus C. Well, if I have like, I don't know, 2 minus 1, if I have A is 2 and C is 1, that's odd. So it doesn't must be even, so no. E plus C. Well, if E is 2 and C is 1, then that's going to be odd. So that doesn't have to be even. B plus D. Well, an even times an even is an even. Now, if it was like 6 and 2, okay, that's still even. If it was like 6 and 8, it's still even. If you have an even number in a product, it has to be even. Let's think about like, even if it was like 4 times 3, that has to be even. Why? Because it's going to be divisible by 2, no matter what. So B and D is our first situation of must be even. A times C. Well, again, like 2 times 1. Okay, that's 2. But what if it was, this could be like 3. 3 times 1. Well, that's 3. Odd times an odd, we find, is an odd. All right? So, like, some things we got to pay attention to. Even times even is an even. 4 times 2. Even times an odd, we find, is even. 2 times 1. 4 times 3. Odd times an odd is odd. Cool. Let's look at sums. 4 plus 2. All right, well, if we have an even number and I add an even number, it's going to be an even number. What about even plus an odd? 4 plus 1. Oh, that's going to be odd. What about odd plus odd? 3 plus 1. 5 plus 3. Even. Okay, so these are like some things that we can think about. All right, B plus D. Well, B has to be even, D has to be even, so even plus even's got to be even. B plus D, which has to be even, we know, times A plus C. A plus C could either be even or odd. I'm not sure, because A could be an even, C could be an even. A plus C is either even or odd. Well, here's the thing. An even times an even is even. An even times an odd is even. So this is guaranteed to be even. Use different numbers if you want to as an example. A times E. A could be even or odd. E could be even or odd. So we could have a situation of odd times odd, which is odd. So no, this does not have to be even. C times D. Okay, D is even. C is even or odd. I prefer doing this. Even times even is even. Even times odd is even. So we get that this has to be even. C times E. All right, we kind of just did that. It could be even or odd. If you have odd times odd, then it's odd. Could be odd times odd. This could be odd times odd. Cool. All right, now this is an odd function. What must be true for an odd function? We can't have any shifts up or down, and these exponents have to be odd. All right, so you guys try. Write down what all your things could be. We got even times even times odd times odd. Write down what those are. Now, A, C could be even or odd. Let's do even plus even plus odd plus odd. You guys figure out what those are. 4 times 2, 4 times 3, 3 times 5. 4 plus 2, 4 plus 1, 3 plus 5. Boom. Okay, that'll help us. Here we go. A plus C, even or odd. We're going to figure out which ones must be odd. Well, here's the only two situations to be odd. Even plus odd is odd. Even plus even is even. Odd plus odd is even. So this could be even plus even. It could be odd plus odd. So no, this is not odd. B plus D. Ooh. Odd plus odd is for sure going to happen. An odd plus odd, 5 plus 3, 7 plus 5, 7 plus 1. This has to be even. Now, it's guaranteed to even, but it's not odd. A times C. Well, we don't know what A and C are, so it could be one of these two situations. So, nope. B times C. Oh, odd times odd. Has to be odd. Odd times odd. 2B plus D. Okay, so this is an even times an odd plus an odd. Even times an odd is an even. An even plus an odd has to be odd. That's nice. This is odd. B squared plus D squared. Okay, this is an odd squared plus an odd squared. An odd times an odd is an odd. An odd times an odd is an odd. An odd plus an odd is an even. It has to be even. It has to be even. It's not odd. B cubed. Odd times an odd times an odd. Odd times an odd is an odd. Odd times an odd is an odd. This is odd. That's silly. B squared times D squared. Odd times an odd is odd. Odd times an odd is odd. Odd times an odd is odd. This has to be odd. B plus 1 plus D. B is odd. Odd plus an odd is an even. Even plus an odd has to be odd. Okay, so it really helps if you have like all of your situations for adding and multiplying things down. Because like if you try to like think about it every single time, it's tricky. Having these all listed down helps tremendously. Cool. That's it. That's it. That's homework. That's kind of even versus odd functions. Where is it useful? Again, I feel like this unit is all like helpful with programming, computer programming, simplifying things. If you understand the left side of your function is going to be the exact same as the right side of the function, you don't have to worry about the entire graph. You just have to worry about like half of the graph. If you know the left side of your function is opposite your right side of the function, it's the same deal. You don't have to worry about the entire graph. You just worry about half, and then you'll know what the other half is. So understanding if you have these characteristics, you have more information without having to analyze as much. Maybe that's the deal. Anyways, that's it. That's Unit 5. Test coming up the end of the week. Later.